Dear students, in this very short video, we will start paper chromatography. It's a separation technique and it's type of partition chromatography where we have two phases, mobile phase and a stationary phase. Stationary phase is normally water that is trapped or absorbed on the solid sport, and that solid sport is usually cellulose. That is actually the paper is used that is made up of cellulose, and water is present there on the cellulose or trapped within the cellulose fibers. It is immovable. That's why that water is termed as stationary phase. And that solid sport or cellulose is ideally inert in nature, that it will not take part in the separation process, but essentially the stationary phase and mobile phase will interact with the solute. But practically the solid sport is not that much inert as ideally it should be. There are evidences that solid sport through adsorption or ion exchange can also affect up to certain extent the process of separation, but theoretically it should be inert. So we will consider it as inert, and we have solute components which will interact with stationary phase and mobile phase. Stationary phase is water that is held in the cellulose, and mobile phase is some other liquid. For example, it may be, let's suppose, an alcohol like butanol, it may be acetone, maybe phenol, or sometime it is used as a combination of, for example, phenol and butanol and water, or acetone and water and acetic acid. So we need a desired polarity. That polarity which can be used to separate our components present in a mixture by their interaction with the polar water as a stationary phase and less polar or non-polar mobile phase. And this separation is actually governed by distribution constant, that is Kc, the concentration of solute in the stationary phase divided by the concentration of solute in the mobile phase. So that ratio actually is equal to distribution constant. It means that a larger distribution constant value means your solute have more interaction or solubility with the stationary phase than mobile phase, and vice versa.